Emily, sorry I missed you on the Zoom meeting again today. I'm going to go ahead and make you a video, so hopefully you can watch this. I know you're getting ready to take the unit test. First, I'm going back to that technology lesson, to the assignment. You do have to get a 70% or higher, and you got a 50%, so I've reset that activity. The next time you go in, it should make you redo it. But let's talk about it. So here we are in the first frame, and I believe now that I can see this, I remember that when the check mark is red on my end, that means you either got it right with assistance or they gave you the right answer for you to put in to continue on. So on that one, I'm not sure what you missed, because it looks like we didn't get this entered incorrectly. So that negative sign on the 12 comes from the key that's just to the left, or excuse me, just to the right of 0. You just tap it. It gives you a negative. In order to get that multiplication sign, which is an asterisk, that's above the number 8. So you have to hit Shift and then press the 8 key. That will give you the multiplication sign. And then you type 27 to get negative 324. So I'm not sure, again, what the error was, but that's what it should have looked like. In this example, it looks like you, again, gray check marks mean you should have picked it, but you did not, and red X's mean you did pick it and you shouldn't have. So let's just focus on these two. You did correctly pick this one, and you correctly did not pick that one. So in the first one, I'm just going to type 2x plus 4y equals negative 26. And then I'm going to zoom in, because 0.5, this graph is going by ones, and so I'm going to zoom in a bit and kind of move this graph so I can see the line, and I want to know where 0.5 is. If you put your cursor on the line, it'll give you a red dot that you can kind of scroll with. So that's what I was doing, and I just went to where, there it is. I went to where x is 0.5. Oh, that was my mouse, moved it. There we go. I went to where the x is 0.5, and you can see that the y is negative 6.75. So that equation does contain that point. We should have checked the first one. Again, if you maybe didn't type something in correctly, then that could explain why we didn't pick that one. 2y equals x plus 13. This is the next one I'm going to do. See, I'm going to have to zoom out to find where the line is. And here it is, way up here. So again, I'm zooming in a bit because I want to find that 0.5 mark. And there it is. And this one, oh, come on. Is 0.5, but it's positive 6.75. And so in the problem, it was looking for negative 6.75. Remember, that would have been way down below the x-axis. So that one should not have been selected. Use the graphing calculator to graph the line. X plus y equals 25, which gives you the best view of the line. So you picked from negative 10 to 10 on the x, and from negative 10 to 10 on the y, which is really where this window is set right now, but I can't even see the line. So this is not a good view, right? Remember, the min and the max is how far left and right do we go, and how far for the y minimum, negative 10 to 10, how far down and up do we go? So I can't even see the line. I got to zoom out. So there it is. Let's see, the x min is 0, so that would be this. That's the y-axis, all the way to 30, so they want us to zoom a bit. There's 30. And then from 0 to 30 there. Yeah, that does give a good view of the line. Without checking these other ones, the line just must not be in the window pane. So you do kind of have to move that around. But remember that the x minimum and maximum is left and right. So you're reading, let me zoom in a little bit so we can get some more numbers. The x, max, and min, if I switch to a highlighter, you're going, no, it's not a highlighter. Do I have a highlighter? Looks like a highlighter. No, I'll just switch back to pencil. So the x, max, and min is here, that direction, and then the y, max, and min is this direction. And you're really just looking at the labels on those axes. Which quadrant will the line y equals negative 1/4 x, oh, that keeps going. Get that x out of there. You want the x not in the denominator. You want the x outside. So when you hit the / to do a fraction, you saw my cursor was down here. I don't want my x down there. That's a very interesting kind of graph when the x is in the denominator of a fraction. I use my cursor to get the x out of there, minus 15. So again, it doesn't look like it's in any of the quadrants, but let's zoom way out. And you want to zoom out far enough that you can see all 4 quadrants. So here is quadrant 1, here is quadrant 2, 3, and 4. So you can see that it will never pass quadrant 1 because that line is just going to continue downward and it's not going to come back up in any way and hit quadrant 1. So quadrant 1 should have been selected for that question. Oh, I must have skipped one over here. I did 5. Okay, we're on 6. Graph y equals negative 3x plus 6. Which of the following is true? The line increases from left to right. No, that is not true. It is decreasing. The line crosses the x-axis at negative 3. So when I zoom in here, there's the x-axis. It's actually crossing it too, so we should have not picked that one. The line crosses the y-axis. That's the up and down line, so let's zoom in there at 6. Yes, that is true. As the input increases, the output decreases. So remember with inputs and outputs, we always talk about the input increasing. Then we look at what does the y do? Well, because this line is decreasing from left to right, that's what's happening here. The line does not enter quadrant 2 at all. This is quadrant 2, so that one should not have been picked. And then the point 3.5, 4.5 lies on the line. So now I gotta zoom way back in. 3.5, negative 4.5. Okay, so where's 3? There's 0, 2, so 3 is right here. So I'm gonna focus on that spot. No, I'm not gonna keep going. That was 3. Let's get to 3.5. Is it gonna fit? There it is. 3.5, negative 4.5. So again, the check marks were the ones you should have selected, and the red X's are ones you should not have selected. So taking a look at that one got pretty mixed up there. So make sure you're getting straight what's the x-axis, what's the y-axis, and your quadrants. Hopefully you have a graph of that somewhere. Explain how you would use the interactive table to tell if sets of points are all on the same line. I would enter all the points in the interactive table. If the result has a line through it, then I know that all the points are on the same line. Yeah, plot the points, graph the points, draw a line, check. Okay, yeah, that's good. On questions like this, I really tell students, I know it says check everything that your answer should included. If you're ever questioning, should my answer have included that, or did I include that? If you're questioning it, I would just put a check mark. There's no sense in losing points here on this part, because I actually don't grade that. It doesn't let me grade those. Okay, which point also lies on the line formed by the data in the table? So here's the table. We're going to put negative 7, 0, negative 6, 2, negative 5, 4, negative 4. And so now we're checking what else is on that point, on that line. So negative 4, negative 9. I can't even see that. Can I zoom on this? Nope, can't drag that. So negative 6, negative 10. I can't even see that. What are we going by? We're going by 2's here, and we're going by 1's there. Okay, so remember, we can actually extend this table. Remember that as we keep going, 6, 8, 10, right? I'm going by 2s, the same thing the table's doing. This is increasing by 1, negative 3, negative 2, negative 1. So there's that point. That one's not there. If I wanted to go the other direction, negative 4 and negative 6, just to make sure I could see these 2 points in my table, we're going down 1, so that would be negative 8, not negative 9. And that one would be negative 9, not negative 10. So you can extend those tables. Remember, we learned that if it's linear, the table will increase by the same number in the x values, and it will increase or decrease by the same number in the y values as well. That one you got, and that one you got. Okay, so that's cool for that one. Now I also want to look at the unit test review because you did do this already, and I want to go over the questions that you missed. First question says, if j and k are non-zero integers, which pair of points must lie in the same quadrant? So jj and kk. That first one you picked is not true because if j could be negatives and k could be positives. So if they're negatives or positives, then they would be in different quadrants. It's always going to be the one with multiplication if you're not multiplying or dividing by negatives. So in this, the reason why this one works is because if I am multiplying by j and k, or I'm dividing by j and k with the number 3, the signs won't change. So let's just show you an example. Let's say that j is negative. If j is negative, then 3 times a negative number is still a negative number. We'll say j is negative, and we'll just say k is positive, just to show you one route where it doesn't change. And then if k is positive and I multiply by 3, right, I get a positive number. So that's the first part. But now let's look at division. If I take 3 and divide it by a negative number, I'm still going to get a negative. And if I take 3 and divide it by a positive number, I'm still going to get a positive. So in that case, you could see these two ordered pairs would still be in the same quadrant. A lot of times on questions like this, I tell students just to pick some numbers for j and k and see what works. Try not to just pick positives. Pick one positive and one negative. A lot of times that will help you see that by changing what you're multiplying or adding by, that things will change quadrants. Question 3 says, which ordered pair can be included in the table of values shown below for that equation? So this could be one where you're just plugging things in. Remember that in these ordered pairs, x is the first number, and in this case they're using p for, I don't know, it could be price or something. Sometimes they'll change the x and y. But if we look at the equation, let's see, going by 6, okay, these are all mixed up. We're just going to look at the equation. We're just going to plug in the numbers and see what works. So the ordered pair you chose says I'm putting negative 2 in for x, and that when I compute this, I should get negative 2 for p. But 25 times negative 2 is negative 50, and negative 50 minus 2 is negative 52. So that doesn't work. So now let's try the one that did work. Let's go up here. So now I'm going to plug in 0 for x and see if we get negative 2 for the y, or for p in this case. 25 times 0 is 0, and 0 minus 2 is negative 2. So there's the ordered pair that works. Question 9, Sarah spends a total of $60 based on the information in the table. How many people attended the craft demonstration? So people attending, let's see, as more people attend, the cost goes down. Based on the information in the table, how many people attended the craft demonstration? Okay, I paused the video to try to save some time so you didn't have to watch me do all of that. But so what I did in this table was I started looking at, if I go from 5 to 8 people, that's 3 more people. 15 to 18, that's $3 more. If I go from 8 to 10, that's 2 more people. 18 to 20, that's $2 more. If I go from 10 to 15, that's 5 more people. 25 or 20 to 25 is $5 more. So I just threw 60 underneath 25. That's $35 more. So I would expect 35 more people. So we're looking for a pattern in that table. This is an instance where it probably costs Sarah some money up front, but then it looks like it's about $1 per person after that. Since we're adding 5 people, we're adding $5. We're adding 50 people, so then there's the $35 more after the 15. There's a cost up front in this, and we could come up with that equation if we wanted to. We could calculate the slope. And then it looks like maybe she's got like a $10 out-of-pocket expense. But that's what I did with the table, just looking for that pattern to answer the questions. And then the last one you missed, it says which one is linear. Remember that linear functions are straight lines. So the one that you selected here, this is not a straight line at all. It's got a curve here. It changes slope within it. And then the right answer is this one here. So I think if you redo that assignment from the data, the technology lesson, and then if you want to redo, you can redo the review again if you wanted to. I think it does give you different questions to review for the test if you feel a little more confident, but as long as you get a 70% or higher on the review and stuff, then that's fine. Reach out if you have any questions, and hopefully we get to meet next week.